Let's begin with our last part for our lesson, which is the tasks. So, again, we are not going to have any complicated setup. We are just going to have uh, two scripts. So, let's create our scene and the scripts. So, the scene name is going to be lesson 8 tasks, and we are just going to have two scripts. The first one is the player script, and the second one is going to be the delayed starter. So for the player script, instead of directly storing the health there, we are going to store the health in a default C# class and access through all the different methods. Namespace and lesson 8 tasks. So let's create our serializable class first, which is going to store the health. So public class, and it is going to be called health system. And inside our class, we are just going to have the current health, which by default will just set it to the 100. And the public void damage, which is just going to decrease the amount of damage. And if the health is less than 0, then we'll just set it to 0. And inside our player, we are going to decrease the health amount. So let's create an update and private health system. So by default, every health system is going to be pretty simple. So it is directly assigned the value here. And if we just press space, then the health system is just going to take the damage. So that's it for the player. It was a pretty simple task. Now let's go inside the delayed start. So let's create the namespace. Is the lesson 8 task. And as you can understand by the name, we are going to call whatever method which is inside the start by delaying a certain amount of time. So let's create a public float delay. So how much delay do we want? So let's set it to F, and private float timer is 0. And inside our update, do not use a coroutine. So it was 3 seconds inside the task, so I'll just use 3 seconds. And it is going to send a message after 3 seconds, and will only calculate the timer like if it is passed once. So if the timer is less than delay, then we'll increase the timer. And if it is greater than or equal to delay, then we'll debug.log the ready to go. Timer is less than delay, then we'll increase the delta time. Again, it was pretty complicated. So what is the task? Write a script that waits 3 seconds after the game starts before printing ready to go. So the first thing is we need to wait for 3 seconds. And if our timer is greater than equal to delay, then we are going to debug ready to go. And timer. And we'll create a can count. Then we are going to operate the timer. What happened? So if we can count, then we are going to increase the timer. And private bool can count is true. So at the start we can count, and when it is done, instead of enabled, we are just going to set the can count to be false. So it is not going to stop counting. It is going to stop counting. So that was it for both of the scripts. Now let's test them. So the first one is the player. So again, where is the error if so? Again, the script is pretty complicated. I should have decreased it. Let's go inside Unity and timer plus is equals to time.delta time. If can count, timer is greater than equal to delay, then it's called ready to go. Why did I change it? Because it was going beyond 1, 2, 3 levels of indentation. Okay, so again, still it is complicated, but you can understand. So the timer is going to calculate, and if we can count and the timer is greater than equal to delay, then we are just going to print the ready to go. And again, this may not be the perfect method. Sorry. Let's test it inside Unity. So let's create an empty and we'll call it here. And both of the scripts are going to be here. So the delayed start and the player. And when we hit space, the damage is going to take place. And also the ready to go, the 3 seconds were finished. So it printed the ready to go, and let's hit space. So as you can see, the lowest health the player is going is 0. And that was it for the tasks.